Welcome to our series on applied science. We are making it absolutely at a basic level, which even middle school students can understand and build upon the concepts. Many unanswered questions will be looked into, and we'll also understand strategies to develop our skills in becoming a better science student. Matter is the very first topic which I have considered in my videos. In this particular video, we'll look into pure substances and mixtures. We are beginning with a question whose solution will be actually provided in the next video. Here we have a question before you only for you to think how can it be answered and what should you know to answer this particular question. So, as you can see, we need to classify the given matter, and the classification is to be done between a couple of things. One, we are talking about pure substances, the others are mixtures. In this video, actually, you will learn what are these pure substances, which could be either of these two elements or molecules, and mixtures could be homogeneous or heterogeneous. Once you get the knowledge about this, you will be in a better position to answer the problem at hand. I am Anil Kumar. Welcome to our series on matter. Let us clearly understand what are pure substances, what are mixtures, how do we classify them, and answer related questions. So, as many of you know, we could divide matter into two major categories, which are pure substances or mixtures. And these can be further divided into two more categories, which are elements. So, pure substances could be of the form of elements and molecules. To describe what are elements and what are molecules, also a related term, which is, let me write down here, compounds. All this will also be discussed in another video in the playlist. You know, all the details cannot be provided in just one video, so we are specifically looking into few things, and all the related keywords will be described in our playlist. So feel free to explore and learn. As far as mixtures are concerned, they could be having two or more substances evenly distributed. We call them homogeneous, or you could see those particles separately, and therefore they are called heterogeneous. Let me write down here heterogeneous. Perfect. So, this is a broad category in which the matter can be divided pure substances and mixtures. Now, as I said, pure substances could be of the form of elements or molecules. Molecules are also referred to sometimes, special cases, as compounds. Mixtures could have uniform set or mixing two or more substances homogeneously or heterogeneously. So now let's dive into what really a pure substance is. Now, when I discuss pure substance with you, after this, I will also share with you notes. It's very important that when we learn, we also make notes of our learning. And you may skip upon few topics or keywords while we are discussing, but not to worry. Listen carefully, make your own notes, and then we'll follow up with the section where I've typed out some key points with you, essential for the topic under consideration. Now we'll talk about pure substances. So, matter, you've seen the periodic table which have elements, right? Many elements are known, right? Now, these elements may or may not exist in atom form, right? So, elements have one type of atom, right? And a specific structure and properties of that particular element. Now, elements which appear as one type of atom are mainly your gases like argon, neon, helium, not in any particular order, right? So you remember this is a group of known gases which are called inert gases. Let me write down here inert gases. Now, all these gases are inert, means they can appear in the atomic form. You get the whole idea. They are not very reactive, and therefore, you know, when we talk about argon or neon or krypton, helium, all these gases, you will see that their atoms are there uniformly distributed. The other example of sometimes material which are available in elementary form are gold, diamond. Now, diamond is a kind of carbon. It is available in pure form, gold also. But most elements are very, very reactive, and therefore they are not really available in elementary form. So they bind together to be stable. So stability is another very important topic, including reactivity of elements, which will be considered in another playlist. Now, the other elements which I'm talking about is, for example, we say hydrogen, right? Now, hydrogen is very reactive, and normally you see two atoms combined together, and this is what we call molecule. You get the whole idea. Water, for example, is a compound, right? So it's not a pure, it's a pure substance, but water is again a combination, right? So again, it's a molecule in which two hydrogen atoms join with oxygen, and these molecules are there in water. So the property of water is similar to that of a molecule of water. Now, many times when we talk about bulk, right? So, like water, pure water in a beaker, we may refer to such things as compounds. However, there is a critical difference between molecules and compounds. As you can see, hydrogen is not a compound. For a compound, we need at least two different atoms. You get the whole idea. So, what I've done here is told you that pure substances could be elements or could be molecules, right? And I've also given you a hint about which molecules can be referred to as compounds and generally when do we call or switch over the term to compounds, right? So that brings us to the notes on substances, which is kind of very critical. Now go through this set of pure substances notes. It says pure substances. Pure substance is matter with single type of particle. Now this particle is basic particle, atom or molecule which has the whole characteristic defined for that particular substance chemically. They are classified as elements, means only one type of atoms exist, or molecules where two or more type of atoms exist in fixed proportion. Like H2O, we know the ratio in which hydrogen and oxygen combine together. Elements cannot be broken down physically or chemically, right? The gold remains gold. As you may just break down that piece to smaller and smaller particles, ultimately you will end up with the atom of gold, which retains the properties of gold, right? So, here a word of caution, do not jump into electrons. Electrons are not particles, to be very precise. Matter, we are looking for particles which have mass and occupy space. Molecules can be broken down into elements by chemical methods, not physical. So, this is very important. So, when you're talking about molecules, they can be broken down into elements. Water can be broken down into hydrogen and oxygen chemically, right? Not physically. Pure substances are homogeneous with uniform chemical composition. So, mixtures are also homogeneous, right? And pure substances are also homogeneous. So that's something common to both. However, pure substances are homogeneous with uniform chemical composition. Now, they participate in chemical reactions to form predictable products, right? So, acid and bases, when we react them, we get salt and water, for example. It's called a neutralization reaction, which we'll also consider in another set of videos. They have fixed melting and boiling points. So there are so many other characteristics, chemical and physical, which are fixed. However, melting point and boiling point is something very basic. And we are going to use this property of a pure substance in separating out, mixtures of different items like air. You get the whole idea, and that's why I have included this in my key points for pure substance. So I hope you understand and appreciate the approach. We talk about it. While we talk, we may not discuss few points. However, here is a complete list for you. And don't forget about particle theory, right? And its connection to whatever we are talking about. Whenever we say matter, all concepts of matter at this level will be connected with the particle theory. So, all particles of pure substances are identical, means they have the same properties and are different from other pure substances, right? So, if I take gold, if I take silver, gold has its own set of properties which are different from that of silver, and that is why they are two different elements. So, I hope this concept is absolutely clear. And with that, let's now talk about mixtures, right? It's perfect. So, and also make a note of whatever we are talking here, right? Okay, great. So, mixtures, let's discuss what could be the mixture when you combine two or more things, right? So, basically, we are saying two or more substances. And this combination, whichever is being done, is more physical in nature. Well, there may be chemical reactions taking place, however, they are not completed. Now, when these two or more substances are combined to form a mixture, here's another very important thing, that they can be separated physically. You get the whole idea. So they can be separated physically, means if I add salt to water, it does form a solution, right? Saline solution, and can be very easily separated by evaporating the water out of it, condensing it, collecting water on one side, leaving behind the crystals of salt. You get the whole idea, right? Another important part is that properties of substances are retained. You get the whole idea. For example, if I add silver particles to carbon and use them in a band aid, for example, silver has its own properties of killing the bacteria, and carbon has the property of absorbing the odd gases. Both these properties are maintained, and you find a mixture of these two in band aids. Huge application. You get the whole idea. So, the property of each constituent substance is retained in mixture, and that is why mixtures find a wide variety of use. You get the whole idea. Mixtures are also used because pure substances are very expensive. So you cannot afford them. For example, diamonds, pure diamond is too expensive. But if you have to sell diamonds in the market, there could be small defects, impurities in it, and they sell easily. Again, very viable for business. And also properties of matter. You can make them more malleable, like jewelry which you make. Let's say from gold, the impurities in it help to get a product which is more usable and lasting. Similarly, there are many other things. So I hope you got the idea. And the two categories which we're talking about is, for example, if you take a saline solution, right? And on the other hand, you take a granular bar. So you can very easily see that these are different kinds of mixtures, right? This is homogeneous in nature, and that is heterogeneous. Heterogeneous means different. Every bite you take from different places of a granular bar will taste differently, correct? As far as the saline solution is considered, it will be exactly same. Perfect. So now the question comes, why saline solution is not considered as a pure substance? Because the two things mixed together are not always done in a fixed ratio. You get the whole idea. In saline solution, you can just keep adding salt as much as you want as per your taste or as per the requirement. So it remains a mixture. So there's a very fine line which actually divides the two, right? So I hope now you appreciate, and these are the notes on mixtures. Perfect. Feel free to write your comment, share your views, and in case you really want to learn from me and have a good perspective of science and be a good student, you can always contact me on globalmathinstitute@gmail.com. Feel free to write your suggestions so that we can take up your questions in the next video. So mixtures, let's now go through these notes which say a mixture contains two or more pure substances that can be separated by physical methods. Mixture can be combination of solid, liquid, and gas. That's kind of very important statement here. You can give examples. For example, air is mixture of so many gases, right? And there are sand particles also in the air. Perfect. Solids, alloys are very good examples of mixtures which are in solid form. Stainless steel, right? Brass, bronze. So copper with zinc, copper with tin forms very useful alloys, right? Now, liquid form laminate we have taken up. Now, another point here is solutions we are writing home. Even a alloy is called a solution, by the way. Homogeneous mixtures, where we have uniformity like in lemonade, right, are mixtures in which substances completely mixed or dissolved, right? Examples are air, steel, brass, wine, coffee. They just get dissolved into one another uniformly. So that is homogeneous mixture, right? The other category is mechanical mixture or heterogeneous mixtures have non uniform mixing where individual substances can be seen or felt. Concrete, cookies, granola bar, salads are examples of mechanical mixtures. Once again, connection with particle theory. All particles of a pure substance are identical, have same properties, and in mixtures they retain those properties. Yeah, right? And different substances have different types of particles. So with that, we have come to an end of this video where you have understood the type of mixtures, right? And now I think you are in a position to classify these items: diamond, oxygen, air, ash, pure water and seawater, concrete, brass, and ozone into the categories mentioned here. So I will appreciate if you could really write down as pure substances of this form, right? For example, right? Or mixtures this type. So that is what we expect from the learnings. And in the coming videos, we have many other questions on mixtures to solve. Feel free to write your comments and share your views. Thanks for your valuable time and suggestions. All the best.